In this video, I am going to explain about plotting shear force diagram and a bending moment diagram for a simply supported beam having point load using Ansys Workbench. Plot shear force and a bending moment diagram for a simply supported beam having area of cross section of 0.2 into 0.3 meter as shown below. Young's modulus of 210 gigapascal and Poisson ratio 0.27. So this is a simply supported beam, 4 meter span, 20 kilonewton point load that is acting at the center of the simply supported beam. So we have to plot the shear force and bending moment diagram using Ansys Workbench. See, this is the shear force diagram and this is the bending moment diagram. Okay. So go to Ansys Workbench, take static structural, click on engineering data, create a new material, steel, entering Young's modulus and Poisson ratio. Young's modulus 210 e raised to 9. Poisson ratio 0.27. Then click on geometry, right click and select design modeler. Ensure unit is in meter. Click XY plane. Click on look at. Create points. Manual input. Generate. Create points. Manual input. 2 meter generate. Create points. Manual input. 4 meter generate. So we have 3 points. So create line between these points. Apply, generate, then construct cross section rectangular, zero 0.3, 0.2, generate, view cross section. So this is the beam. So minimize it, click on model. Select material steel. Then go to mesh, generate. We have to change the element size into smaller value for getting better result. Click on static structural. So we have to give the boundary condition. That is essential boundary condition. We have two type of boundary condition, natural boundary condition and essential boundary condition. So we have to give the essential boundary condition. Here this is simply supported beam, not cantilever beam. So in the case of simply supported beam, one end is a hinge support and another end is a roller support. So here a hinge support and here is a roller support. So as it is a hinge support, there is no transverse movement, rotation only here. And here is a roller support, there will be no rotation, only movement in x direction. Okay, so I will explain. Click on support, select simply support. Here at this point there is a simply support. So what's the importance of simply support is, here there is no movements in lateral direction, xyz direction, but rotation will be there. as it is a hinge will be providing. And at this point, at the opposite point, there is a roller support. So we have to take remote displacement and click this point, apply. So at this point, there is only rotation, there is only rotation in Z will be there, and movement in X will be there. Rotation Z will be there and movement in X will be there. So X will be free, Y constant, Z constant, rotation X constant, rotation Y constant, rotation Z will be there as it is a roller support. It will rotate in Z axis and move in X axis. Then we have to create the path for plotting shear force and bending moment diagram. Okay. Then we have to apply the force. Force. Okay. See, this is the applying force is the natural boundary condition. We have two type of boundary condition: essential boundary condition, natural boundary condition. Essential boundary condition we have already applied here. This point simply support and remote displacement, and at center point we are applying force. That is the natural boundary condition. Okay, we have two type of boundary condition: essential boundary condition, natural boundary conditions. Then click on insert beam result shear moment. See, you can see that this is the shear force diagram and this is the bending moment diagram and this is the deflection. So this is the deformation. So you can see the what is happening in the deformation. Okay. So this is the shear force diagram and this is bending moment diagram and this is displacement. So in this way we are plotting shear force and bending moment diagram in the case of simply supported beam. Okay. Thank you.